Hi guys, so today it's Monday. It's March 23rd, 2020. Again, it's still the period of time for a pandemic. And here's the lesson for, excuse me, 3.10, 3.10, linear approximation and differential. So let's just record that the point of slope form back to algebra 2. It's considered, well, back to algebra 1. It's y minus y1, so that equals m times x minus x1. Okay, so but in the calculus approach, so this one we just want to write it a little bit differently. So for y, it's considered f of x minus y1, so it's f of a, and then m, that's just like f prime of a, and then x minus x1, so x minus a. So where x1 is the same as the value of a. So for the equation of a tangent line at x equals a, so try to verify that, try to solve for f of x by itself, which is f of x, or y. So eventually you'll end up with f prime of a times x minus a plus f of a. So this one, it's exact same formula that we're using for linear approximation. And then for the calculus approach, the Cal BC, they're using that for like a Taylor series, for the tangent line, and also the Maclaurin series. But this one is just like an early introduction of the linear approximation. So you'll see some example in just a second. Okay, so now let's take a look at that. So how do we find the linearization formula L of x for the function of x at x equals a for the following? So again, so we're going to use that L of x. So that equals f prime of a times x minus a, and then plus f of a. Okay, so first thing that you want to do, you want to take the derivative, so f prime of x. So derivative of cosine of x, which is negative sine x. And you want to find out what f prime of a is. So negative sine of power 2. So we do know that sine of power 2 is 1, so it's negative 1. And then by plugging the number, so we do have L of x. So that equals negative 1 times x minus a, so x minus power 2. And then plus f of a. So f of a is just cosine of power 2. So let's find out what that is on top here. So cosine of power 2, which is 0. So plus 0. So the way to approximate this function with any number, so it's negative x plus power 2. Okay, so for cosine of x. So we can say that cosine of x, it's negative x plus power 2. Oops. Try to box it. Okay. And now let's take a look at that, the other one. So once again, it's the same process. So f prime of x, so which is 1 over x. And you want to find out what f prime of a is. F prime of 1, so it's 1 over 1. And that's what we got. And then f of 1, so natural log of 1, which is considered 0. So using that, the linear approximation formula, so L of x, which is considered f prime of a, 1 times x minus a, x minus 1, and then plus f of 1. So that means for this natural log of x is similar to x minus 1. Okay? So now let's see what else that we have for the rest of the slide here. So now, linear approximations, another thing that we use in the daily life. So instead of using calculator for any of this, so sometimes we're using that for doing like mental math. So here's some of the example that we can find out by using the linear approximation. So 2.001 to the power 5, a lot of people probably just use calculator for this. But instead of using calculator, we can always use the linear approximation. So let's set up the function first. So for f of x, so we want to set that as 2 to the, let's see, it's x to the power of 5, okay? So for f prime of x, so that means it's considered 5x to the power of 4. So again, using the linear approximation, so for x, we do have 2.001. And then for the value of a, well, let's say that we're using the closed number, 2. Okay, so again, linear approximation, so it's L of x, so that equals f prime of a times x minus a plus f of a. Okay, so just like the point slope form, or you can say that this one is just the slope intercept form. So f prime of a, so by plugging a number here, so f prime of a, we do have f prime of 2. So we got 5 times 2 to the power 4. So 2 to the power 4, which is considered 16. 16 times 5, then that would be 80. So start with that, 80. So times the quantity of x minus a, so 2.001 minus 2 plus f of a. So f of a, which is 2 to the power 5. So then that would be considered 32. So we got 80 times 0.001 plus 32. So 0.001 times 80, then that would be 0.08. 0.08, because you want to move the decimal point one place from left to right, because you multiply by 80. And now let's see what else that we have for the rest of this. Plus 32. So eventually the answer is 32.08. If you try to do that on the calculator, the answer should be pretty close. And now what about for tangent of 44? So now for this one here, we need to convert that degree to radian first. If you try to use degree using the linear approximation method, so the answer might be a little bit off. So before you do that, you want to convert that 44 degree to radian. So the closest perfect square, the perfect angle would be 45 degrees, so it's pi over 4. So let's say that it's the value of a. And then 44 degree, convert that to radian, multiply by pi over 180. And then this one, if you try to reduce it, divided by 4 top and the bottom. Well, let me just get some more space right here. Okay, maybe I should do on the new slide here instead of erasing it. Okay, so tangent of 44. Okay, so tangent of 44 degree. Again, first thing, convert the value of x to radian. Simply multiply by pi over 180. Cross cancel, so divided by 4 top and the bottom. So we do have 11. Divided by 4 by 180, so we do have 45. So it's 11 pi over 45 radian, rad. Again, the closest angle would be considered 45 degree, so convert that to radian. So this one you end up with pi over 4. Again, linear approximation, so L of x, so that equals f prime of a times the quantity of x minus a plus f of a. So for the function here, we determine the function is considered tangent of x. So that means f prime of x would be the derivative, which is secant square of x. And then f prime of pi over 4, f prime of a. So then that would be secant of pi over 4 quantity square. So secant of pi over 4, we do know that it's considered 2. Because that cosine of pi over 4, it's, well, let's see. No, it's actually root 2. So root 2 quantity square, then that would be 2. Again, cosine of pi over 4, that's 1 over root 2. Okay, so the other way around, then that would be secant. So root 2. So root 2 quantity square, then that would be 2. And also let's find out what f of a is. So f of pi over 4. So tangent of pi over 4. And that just consider 1. Okay, so plug in a number, f prime of a. So we do have 2 times x minus a. So x, which is 44 in terms of radians. So it's 11 pi over 45. Minus pi over 4. Again, we're using radian for this. And then f of a, well, what's f of a here? So f pi over 4 plus 1. And then the rest of that just simply subtract. Okay, it's all about pre-algebra. So find the least common denominator, 45 and 4. Then that'd be 180. So convert that to 180. So this one, you end up with 44 pi minus 44 pi over 180 minus 45 pi over 180. Then you'll get 2 times negative pi over 180 plus 1. And then try to reduce, so this one's 90. So eventually it's going to be negative pi over 90 plus 1. Okay, so then that'll be the approximation of tangent of 44 degree, or tangent of 11 pi over 45 in terms of radian. Okay, so now let's go back to the slide. So what about for square root of 99.9? Okay, so again, I need to set up the new slide for this. So square root of 99.9. So first thing that I want to do, so let's y equals, or f of x equals square root of x. And obviously x is 99.9. And then a, I'm sure you guys want to pick 100 because that square root of 100 is a perfect number, is 10. So let's find the derivative of y. So y prime, so we do have 1/2, excuse me. So this one would be equal to 1/2 x to the power of negative 1/2. Okay, so now let's find out that f prime of a. So f prime of 100. So it's 1/2 times 100 to the power of negative 1/2. So it's 1/2 times 1 over 10. And then multiply them straight across. So we do have 1 over 20. Again, so this one will give you f prime of a, same as y prime over 100. And now what about for f of a? So f of a is just square root of 100, which is 10. Again, using that formula, so square root of 99.9. So this one, it's going to be approximately, so it's the same as f prime of a times x minus a plus f of a. So using that formula, f prime of a, the one that we found, it's 1 over 20. X minus a, 99.9 minus 100, then that'll be 0.1, but it's negative. And then plus f of a, so plus f of a, so f of a, what we got here, it's 100 square root of 100, so then that'll be 10. Okay, so 1 over 20 times negative 1 over 10 plus 10. So negative 1 over 200 plus 10. Okay, or you can just convert that to a decimal if you want to. So eventually, so it's negative 1 over 200 plus, well, this one is 10 over 1. Convert that to 200 times 200 top and the bottom. So 2,000. So eventually it's going to be 1,999 over 200. Okay. So any questions that you have, so please feel free to ask me about that either from YouTube or send me the email through either Google Classroom or Schooloop. Okay, so now let's go back to the original slide here and see what else that we have for the rest of us. Okay, so for the differentials, so differential is showing that dx and dy. So you see the graph right here, so dx is the same as delta x. But the thing is that dy is the difference of the y value. So let's say we do have 2 points here. So dy is just like a rise, okay? It's like y2 minus y1. But delta y, that's the differential. That's what we need to find out. So if you just want to fill in the blank here, f prime of x is the same as delta y over delta x. So for delta y, so this one can be written as f prime of x times delta x, or the same as f prime of x times dx for the differential. So for delta y, it's called the differentials of y, and then dx, it's called the differentials of the x values. Okay, so now let's find the differentials dy by evaluating dy for the given value of x and dx. So a couple things that I can do here. So y prime, so we can just rewrite it as dy over dx. Again, so it's the same as y prime. So for the derivative of this, then that'll be considered e to the power of x over 10. but don't forget about the chain rule, so it's 1 over 10. So dy, which is the same as e to the power of x over 10 times 1 over 10, and then times dx. Okay, so for dy, we just isolate that. So just imagine that just like a variable, and we try to isolate it. And then plug in the value of x, so e to the power of 0 over 10 times 1 over 10 dx, 0.1. So e to the power of 0, that's 1. 1 times 110, that's 1 over 10. So it's 0.1 times 0.1, which is 0.01. And that's the differential of dy. And now what about for the next one, secant of x, given that x is power of 4, dx is negative 0.1. Again, same process. Find y prime, which is dy over dx. So we do have secant x, tangent x. And then solve for dy by itself. So we do have secant x, tangent x, and then dx. And then by plugging a number, secant of power of 4, so we do have, well, cosine of power of 4, that's root 2 over 2, or 1 over root 2. So secant of power of 4, then that'll be root 2. And then tangent of power of 4, that's 1, and then times negative 0.1. So root 2 times negative 1 over 10. So we do have negative root 2 over 10. Again, you don't want to approximate it, you don't want to round it, so just leave it with the radical, because that's an irrational number. So this one is for dy. Okay, so now let's see what else that we have for the rest of this. So here's one of the word problem, and also it's considered one of the homework problem you're going to be doing for this sections, 3.10. So the edge of a cube was found to be 20 centimeters. So the edge, so that means the side length. So let's say we do have a perfect cube. Okay, so I don't have any three-dimensional object here. So maybe I should draw one. So let's say that we do have a perfect cube. Okay, like this. So the side length is 20 centimeters. Well, again, if that's a perfect cube, that means all three sides got to be equal. So the height, the base, the length got to be exactly the same. So with the possible error of the measurements of 0.1 centimeter, so 0.1, that's considered ds, which is the differential. And use differential to estimate the maximum possible error, the relative error, and the percentage error in computing the volume of a cube and the surface area of a cube. So the way to find the volume of a cube, it's always consider v equals s cubed. So take the derivative. Okay, so this one, it's about dv over ds. So that equals 3s squared. Okay, so we just want to take the derivative with respect to s. Got to be careful with this. It's not a related rate problem. There's no time involved, okay? It's just a differential. So now let's find out the volume. Let's find out the percentage, well, the possible error in the volume. So for that dv, we just solve for dv. It's just 3s squared times ds. Okay, so by plugging a number, so we got 3 times 20 squared times ds, which is 0.1. And then 20 squared, so we do have 400 times 0.1, which is 40. So 40 times 3, which is 120. Okay, so that'll be considered dv. Excuse me. And that'll be the possible error in the volume. And now, what about the relative error? The relative error, that means it's considered dv over v. So the difference of the volume, it's 120. And then over the original volume, which is 3 times 20 squared. So 3 times 20 squared. Well, actually, it's not 3 times 20 squared. The original volume, it's 20 to the power of 3. because the one that I'm using here, that's just a differential. So 20 to the power of 3, which is 400 times 20, and that'll be considered 8,000. So the relative error is 120 over 8,000 reduced. So 0 got canceled. So 12, 800, so divided by 4, so we got 3. Divided by 4 here, we got 200. So 3 over 200. And then what about the percentage error in the volume? So basically whatever that you have here, so just convert that to 100%. So divided by 2, top and the bottom. So 3 over 2, which is what, 1.5? So it's about 1.5%. Okay? So this number is a little bit big because that the difference of the side length here, it's about 0.1 centimeter. So everything has been like triple. Okay, so that's why this number is being big. And now what about for the surface area? How do you find out all those error for the surface area? Okay, so let me open up the new slide here. So again, so the side length, we do have 20 centimeters. And then the differential for the side length, it's 0.1 centimeter. And the way to find out the surface area of a cube, so 6 times s squared. So the differential, so dA, that's what we need to find out. So dA over ds, so it's 12s. Okay. And now from here, we just want to solve for dA. So 12s times ds. So simply just take this one back to the right hand side. It's division. You want to do the inverse operation. So 12 times s times 20 times ds times 0.1. So 20 times 0.1, that will give you 0.2. No, that will give you 2. Excuse me. So that would give you 2. 2 times 12, then that would be 24. So that's the difference of the surface area, the differential. Okay, so 24. And now let's find out the okay, so let's find out that the relative error. So dA over A. So dA is 24. And then the surface area for this one. So 6 times 20 squared. So 20 squared, that's 400 times 6. Then that would be 2400. And then reduce. Okay, so that would be considered 1 over 100. Okay. So now let's convert this one to the percentage error. Percentage error, that's just what? 1%. Okay, again, this one is just the possible error for the area. And here's the relative error. And this one is the percentage error. Okay, so again, any questions that you have, so please either put it in on the YouTube channel, or you can just, submit that through either School Loop or Google Classroom. Okay, so thank you for watching the video today.